If we have a particular material, if we know that a particular arrangement gives us the property that we want, how do we get the atoms into that arrangement? What could we do to a bunch of atoms to change the way they're connected? Any ideas? Any ideas of what you might be able to do to a bunch of atoms? Yeah?
Maybe like move around the object if it's soft enough.
Okay, so you could push on it and squish it around? Yeah, that's something you could do. Anything else? Yeah. Yeah, you could melt it. You could change its temperature. Maybe not all the way to melting, but melting would be fine. You could do its temperature. Anything else? How would you change its chemical property? Excellent. Put a different kind of atom in there. Yeah. Those things that you just talked about are what we call processes. It's how we process the materials. And there are basically three different kinds of processes. You can control the temperature. Anything that controls the temperature, we're going to call a heat step. You raise the temperature, you lower the temperature, how long you hold it at a temperature, how quickly you change the temperature. All of those things can affect how the atoms are joined with each other. So we're going to call that a heat step. Okay. Now you mentioned adding a different kind of atom and having a chemical reaction. We can call that a chemical treatment. So that's a treat step. So anytime we're mixing different kinds of atoms in order to get them to react, we'll call that a treat step. And then you can do mechanical things. Push it. You can stir it. You can pour it. You can crush it. You can extrude it. You can mix it. Any of those mechanical things, it's like hitting it with a hammer. So we're going to call that a beat step. So there are three kinds of processes: heat, treat, or beat. And you can use them in different combinations to rearrange the atoms to get the arrangement that you want. Let me give you an example. Up here, I have a bar of pure tin. This is a metal, pure tin. And I have a strip of tin foil. Now, can you think of some process, some combination of heating, treating, or beating this bar that would turn it into this strip of tin foil? Yes, at the back.
Beat it.
So just take it and start hitting it with a hammer. Yeah, that would work. Okay, so that's a beat step. You have another idea?
Beat it and beat it.
I'm sorry?
Beat it and beat it.
So which would you do first?
I would heat it,
Okay.
and then I would beat it really hard so it can get longer.
Okay. And why would you heat it? What would that do to it, do you think?
So it can melt it and you can probably turn like the area.
Okay, so if you heated it as much so that it melted, that would be one. Or you could just heat it up till it got soft so it would be easier to hammer. So that's a combination of a heat and a beat. Any other ideas on how we might turn this into this? Yes? So how would you do that? Well, I was thinking of anything that's really super scientific, expensive. Maybe you could put it into something that would eat away at it until you're left with a very thin layer. What kind of a step would that process would that be? Heat, treat, or beat? That would be a treat step. That would be a chemical reaction. So there are all kinds of ways that you could turn this tin bar into this strip of tin foil. Let me show you one way of doing it. This equipment up here. What I have up here is what's called a solder pot. It's a heater. And I have taken my tin and I've put it in there and I have melted my tin. So what I have here, let me show you, is liquid tin. Okay? Now tin melts at about 450 degrees Fahrenheit. That's about the highest temperature your oven at home goes to. It's really not that high a temperature as far as metal goes. Tin's known as melting at a low temperature, but it's good enough to melt the tin. So what I'm going to do is to take a ladle full of this tin, bring it over here, and pour it into this little slot where it's going to roll down and it's going to hit this drum. So what kind of a step is my first one of taking the tin and putting it in here? Heat, treat, or beat? That's a heating step. What kind of a step is filling this, bringing it over it, and pouring it into that slot? Heat, treat, or beat? No, it's a mechanical step. It's a beating step. It's a mechanical step. And then it's going to roll down and it's going to bond to this piece of stainless steel. So what kind of a step is that? That bonding. Back there. Treat. So this has all three of them in it. So I'm going to take my tin. I'm going to pour it in. Oops. And I'm left with about 30 feet of tin foil. You guys want to feel this on the front row? Be careful, the edges can be a little bit sharp. Now, how many of you use tin foil at home? Are you sure? What would happen if you covered your Thanksgiving turkey with tin foil and put it into a 450-degree oven? What would happen to your turkey? Yeah, the tin foil would melt all over it. You actually use aluminum foil. Aluminum melts at 1,300 degrees Fahrenheit. It's going to stand up to your oven just fine. It's the right stuff for that job. Tin foil is not. The reason we call it tin foil is before they knew how to make aluminum foil, they did make tin foil, and the old name stuck. Same thing with tin cans. Tin cans are not made out of tin. They used to be. They're made out of steel. Okay? But the old names still stick. Okay, here, let me take this back. Now, what you just saw is not the way they make tin foil. It would be too expensive to make tin foil or even aluminum foil this way. But it is an industrial process called rapid solidification. You guys saw how quickly the liquid turned into a solid? Whoa, excuse me. Sorry about the papers. There are atoms that don't really like each other. They're fine if they're in a melt. They'll swim around. But if you start to cool that, they will separate out and the stuff will just crumble. But if you can cool it really fast so the atoms don't have time to separate, they will stick together and they make very, very hard substances. Very good for making bearings, anything that will rub against each other. Sometimes they make golf clubs out of them because they're very hard, and when they hit the ball, they transfer a lot of energy to the ball. So while this isn't used to make tin foil, it is used in industry. This kind of process is used in industry to make some materials with some very special properties